Hi everyone, today I'm going to show you an easy way to implement greatest common divisor or greatest common factor between two numbers. So let me run through an introduction first. Suppose we have a number A, and let's say we divide by B. If we divide by B as a divisor, right, we will eventually get a Q and R. But to get a divisor, right, we want the remainder to become 0. But we are going to ignore this first. So to rewrite the equation, right, we can write it as Q multiplied by B and then add with the R remainder. We will get an A, which is the number, okay, A. So rearranging this equation, we will get A is equal to QB plus R. The Euclidean algorithm say greatest common divisor of AB is equal to greatest common divisor of BR, which is the remainder. This is very important. This allows us to find the divisor very quickly with these properties. You know, the divisor must equal to the divisor of B and divisor of R. By looking at this property, let's check this example. For example, we have GCD of 28 and 12. We want to find the 28 and 12. How should we do it? So what do you notice is, what we eventually do is swapping the number, okay? The B will be put to the front, okay? B will be put to the front, and then what is the second? The second one is just the remainder. If you are doing a remainder, right, you can actually use modulus. So we don't need to run through this step. If you want to run through this step, eventually is just put in the value 28. So 28, we put 28 in here, is equal to Q. Q is the number. We don't know what is Q. Multiply by B, 12, okay, 12. And then add with the remainder. We don't know the remainder also. By substituting a number 1 at a time, we know the largest number of Q is equal to 2. If we try 3 multiplied by 12 is 36, is too large. So 2 is the answer. But we are not going to look at Q at all, okay? Our main concern is just the remainder, okay? So if you use 2 multiplied by 12 is actually 24. 28 minus 24, the remainder is 4. Okay, so we are going to put in this form, okay? Initially it's in this form. GCD of 12, okay? GCD of 12, which is the B, okay? We write back 12, and then followed by the remainder of 4. So how do we know? When do we need to keep repeating this step? We know we should keep repeating this step by checking A modulus B, okay? A modulus B. Doesn't matter what is this value. Because even when you get 12, 4, right, you are going to pass through this again. When you pass through this again, this eventually is just A modulus B. So when you do A modulus B not equal 0, right, you are going to keep finding remainder. So let's see. If 12 modulus 4, right, what is the answer? 12 divided by 4, the remainder is 0, okay? When the remainder is 0, we know the answer is actually 4, okay? 4. There's one property. If GCD of a number and 0, right, what is the greatest common divisor? The answer is A. And GCD of 0 and B similarly would result in B, okay? This is one property. So actually, up until here, we can stop. We can directly return the value of B, okay? So to prove this, how do we know GCD AB is equal to GCD BR? For the proving, we can rewrite this equation as R is equal to A minus QB, okay? R is equal to A minus QB. Let's represent it with D as the GCD, greatest common divisor of A and B. That means A can be divided by D and B can be divided by D also, okay? So that also means any linear combination, okay? Any linear combination can be divided by D. Do you agree? For example, our GCD of 12, 4, right? Say 2 multiplied by 12 plus 5 multiplied by 4, and we divide by 4, okay? Suppose if, say we know the answer is 4, it's the greatest common divisor. We can divide, right? Our remainder is actually 0. then this is correct, okay? Any linear combination is valid. And second property, if our x is equal to 1, okay? Say if our x is equal to 1 and our y somehow is just negative q, okay? Somehow our y is negative q, right? Then what do you get? 1 multiplied by a minus qb is equivalent to our remainder, okay? Remainder. That also means our remainder is actually divisible, okay? Divisible by the divisor, okay? Divisor. With this, we can say that GCD of AB must be GCD of BR also. Because of this property, right, we can keep repeating this step up until we get remainder is actually 0, okay? When we know the R is equal to 0, right, we can directly return the value of this, okay? We return the value of this. With that, we have finished our proving. And one more thing to note is, just now why do we don't look at Q? Q is what? Q is just actually a constant. The constant doesn't guarantee it's divisible by D. But what is guaranteed divisible by D is actually the R. Okay, so we can also write like this.